My name is Roland Lee, and I'm part of Heimdall Data. The session that you're in today, we're going to be going over increased application performance with SQL auto-caching, no code changes. So if you have a SQL backend, then this presentation, I believe, will be relevant to you and you'll find very interesting. If you're not using a SQL backend, you probably won't find it as interesting. Okay, so are you guys in the correct session here? All right. So let's get a survey. Can I have a show of hands? How many use an open source database like MySQL or Postgres? Okay. How many use SQL Server? Okay. And how many use Oracle? Okay. So I think we covered the majority of the databases. Any other database that I did not mention that someone may be using? DB2, okay. SQLite, okay. Anyone else? All right. So the agenda is as follows. We're going to go over the concept of a database proxy. Heimdall data is one of them. And it's a new concept, but it's extremely powerful and very useful for the developer and the DBA. And afterwards, we'll go through a demo. But I wanted to make this very interactive. I know it's not great for recording, but this time is really for you all who are attending here. So if there's any questions or clarification, please just raise your hand and we can have an interactive discussion. I think that makes the session a lot more lively. So what a database proxy is, very simply, is that it improves SQL read-write performance and reliability for the developer and for the DBA. What makes it very interesting is that you get the visibility control of SQL without any code changes. That's the big part of it. You don't have to program to a particular API to get the benefits. It's a transparent solution, and you get SQL control and performance visibility. And I'll show you how it's done. Now, these are the various vendors out there today. Has anyone heard of Proxies SQL or MariaDB? Anybody? Okay. So Proxies SQL is an open source proxy, particularly for MySQL. MariaDB has a product called MaxScale, which is also a database proxy. And as you know, MaxScale is a derivative of what database? Does anyone know? MySQL. Okay, so the two on your right-hand side are database proxies, particularly for MySQL. They are open source. And then moving over to the left becomes more proprietary solutions, but there's added benefits. There's ScaleArc, which typically has been known to be very good for SQL Server. Okay, and then the company that I represent is Heimdall Data. We're database vendor neutral. Okay. And there's a few things that are very notable and that are in common. These proxies support automated failover, query routing capabilities. Some of the proxies are database vendor neutral. Heimdall data tends to be database vendor neutral, so within any database that you're using, it works. But there's a couple things that we're going to talk about that relate to in-memory data grids that we support that you may find interesting. First of all, we automate cache and validation without any code changes. And number two, based on our architecture, we can remove or greatly reduce network latency. Okay? So let's talk about when you would use a database proxy and when you would use an in-memory data grid as a data store. Okay? So I want to get your pulse here. So if you were to use, let's say, a Hazelcast, GridGain, Pivotal Gemfire, Oracle Coherence, Redis as an in-memory data store, there are a lot of benefits to this, right? But what are some of the challenges to using an in-memory data grid as a data store? Not a trick question. Complexity. You have to write your code from scratch, right? So to get the benefits, which is great, which is control and optimization of performance, you have to have a development team dedicated to a particular vendor and write it from scratch. And if you have an existing application and you want to have this data store, you basically have to rewrite and modify the application or refactor, right? So with the benefits come work to do. Now, what if I were to say, so these are typically for greenfield applications, it requires code changes. But if you wanted to optimize and improve the performance of your application, what if I were to say you can get 50% improvement of your database performance by using a database proxy and not refactoring your code? Does that become more interesting? Yeah. Okay. So I think if you get about 50% or above, let's just say I can get 70% of the performance that I wanted without rewriting the code with a proxy, then the conversation becomes very interesting, right? Because what we always say is that a developer should focus on revenue-generating features, not on sustaining and performance improvement. Because in order for a company to make money, they should be really focused on how do they create a leadership, a feature-rich, revenue-generating solutions, as opposed to, hey, how do I make it more performant, right? And if database proxies can help you do that, all the better. So just as a comparison, for an in-memory data grid for a data store, you get the best scale and best performance, as opposed to a proxy it may just be, hey, just good enough. These are typically for greenfield applications, so you write from scratch, from the beginning. You may want to use an in-memory data grid. The proxy is great for both, but it's typically for an existing application, an existing database that you can drop in, and it'll improve performance. Lastly, as I mentioned, to do this requires code changes. A proxy does not. Any questions here on the differentiation of the pros and cons? Okay. So let's talk about what a transparent database proxy is. The way that it works is that it is transparent. It doesn't require code changes, because it may seem a bit fantastic for me to say that. This slide shows you. Heimdall has two software package options. The first one is a proxy. It runs as a sidecar process. It runs as an agent, either on the application server itself or as a separate proxy tier. It's just a sidecar process. So if you were to install it, all the application needs to do is change its connection to point to the proxy via IP and port. That's it. Okay? It's just a networking change. And then the proxy will talk to your database. Okay? No code changes. There is a second option, which is on the right side, which is if you're a JVM, then it can be packaged as a JDBC driver. So you shim in or you insert the jar file in between your application and your current vendor JDBC. Okay? So all you have to do there is the application configuration needs to just change the URL or class path. And that's it. No other application changes. Does this make sense? Okay. On the right-hand side is a URL and class path change. On the proxy side, it's just an IP and port change. It's a networking change. And that's it. Everything else, in terms of configuration, is just GUI driven. Okay? No app changes. So here I'm going to talk about the various features that the Heimdall Data Proxy platform can support. The first one is SQL caching. And I'll get more into it. But what it allows you to do is treat these in-memory data grids as a look-aside cache. It's not a primary data store, but it's a look-aside cache. So this proxy is a transparent platform that's transparent to the application and transparent to your SQL database. And then you're going to hang off a storage of your choice. So we can support Hazelclass, Redis, GridGain, Gemfire, whatever you like, and it's going to store SQL results and perform the invalidation automatically. Okay? And we'll get more into that in another slide. What it can also support, too, is connection pooling. Has anyone, for those who are Postgres users, are you guys familiar with pgpool2 or pgbouncer? Okay. Consider a database proxy as a pgpool2 and a pgbouncer replacement. Okay? It can support connection pooling. It can support automated failover. And by automated failover, what I mean is the proxy can sit in front of the database, monitor and sense the health of the database instance. If it's unhealthy, it will gracefully fail over to the standby database instance of your choice. It does not mean replication. It doesn't do the backend replication. Does that make sense? Okay. Now, it's not your typical failover. One thing about the Heimdall proxy which makes the failover very interesting is just because you have a failover, why don't you just throw a load balancer like HA proxy or an ELB in front of the database? What's the difference? Well, what the proxy does is that once we sense that a failover, an instance is unhealthy, at the front-end application connection, we're going to queue up the connection. And then we're going to gracefully fail over on the back end by creating a new connection and then empty out that queue. So what that does is it greatly reduces exceptions and application errors. When you just have a standard TCP/IP load balancer that fails over, although the failover may be successful, a lot of times the application doesn't like it, and it'll drop the connection, and sometimes it doesn't know to do the retry. Okay? And that's not good for the end user because you have to reestablish that connection. Here what we do is we hold the front-end connection, create a back-end connection, fail over, and to the application, to the end user, he doesn't see that drop connection. Does that make sense? Read-write splits. Does anyone know what that is? What read-write splits is? When you want to scale out the data tier, what people typically do is they have a write master and a bunch of read replicas. Okay? And the reason why you do that is because writes tend to be more expensive, more data processing, and you don't want to send reads, which are considered cheap, over to the write server. So what ends up happening is architects or developers want to have a dedicated write server where all the writes go to and have a bunch of read servers, which you call read replicas. And so when there's reads, just it'll put all the read queries over to the read replicas and not bog down the write server. Does that make sense? Okay. In order to have a write master and read replicas, and when you add read replicas, what you have to do is you need to make code changes. Every time you add an instance or re-architect and scale out, you need to make code changes. Well, what the proxy does is that now it's all rule-driven. So when you add a read replica or you add a write master, it's just, you just tell the proxy and it'll know what to do. It's SQL aware. So the writes will go to the writes and the reads will go to the read replicas. And within the read replicas, the proxy will load balance across the read replicas. That's what read-write split is. It's splitting the write queries and the read queries without code changes. This feature is often popular amongst Postgres and MySQL users because that's how they break it out. Okay. Any questions there on read-write splitting? Okay. The next two on your right tends to be more advanced features, and we'll talk about. What the proxy can do is actually batch processing. So if you have a lot of singleton DML operations, singleton, does anyone know what DML stands for or what it is? DML is add, insert, or delete. If you have a lot of singleton DML to a bulk table, this can bog down the database and slow down performance. So what the proxy can do is aggregate, batch those singleton DML operations under a single transaction and send it over to a database transparently without any code changes. Everything that I'm talking about here, you'll hear me say it without code changes, without application changes. Okay? This is done transparently. So what we found when we were at Dell was that we were able to improve the response times 20 times because of the fact that the commit overhead of each single insert was so heavy that we can batch them together under 64 or 512 batch sizes that have really improved the DML throughput. So that may be a use case of improving write performance where caching is improving read performance. Okay? And then lastly, we can enhance HTAP. I don't know if you remember in the keynote yesterday, they talked about how that is a big trend. Does anyone know what HTAP stands for?
Something transactional analytical.
Yes. Yeah. Correct. You got it. Remember the last, you got HTA, and do you know what P is? Processing. You got it. So it's hybrid transactional analytical processing. So today, when you have a data, does anyone have a data warehouse you guys manage? What do you guys use, out of curiosity? Pardon me? Microsoft SQL. Anyone use Amazon Redshift? How about Pivotal Greenplum? Nobody? Okay. So for data analytics or data warehouse, typically the architect will have to design such that all the OLAP traffic goes to the data warehouse, and then all the transactional traffic gets routed to a transactional database like Postgres, for example. Okay. What we're seeing today from Nikolai, I believe, who spoke yesterday, was that there's hybrid applications now such that there's mixed workloads. There's OLAP and OLTP traffic together. So for those types of applications, what the proxy can do is that it can route analytical traffic to the data warehouse and OLTP traffic, transactional traffic, to a transactional database. So what the database proxy can do is route the traffic to the most optimal data source. Okay. So in summary, you get a toolkit of features that allows you to cache to the storage of your choice. Okay. All it's doing is providing the logic, the caching logic. You just point it to the storage of your choice, to the SQL database of your choice. You get full freedom as to the data source and to the storage of your choice, and you just enable whichever modules that you want. Okay. Any questions here? Yes, sir.
Is it sort of plug and drop, plug and play for the different storage? So you've got group game, Redis. Is there almost an unlimited number of modules you can connect to? Is there a finite list? Is it very well-defined chip?
Okay. So, okay.
More than 4.
Good question, David. David, right?
Nicholas,
sorry. So Nicholas asked, is it a plug and play, and is there any limitation on nodes for the storage? So the answer is there is no limitation on the storage that you're using. So it's based on what your needs are. So and number 2, it's plug and play. So originally what you would do if you were to use, let's say, Redis as a cache, what you would typically do is have to write into the Redis API. You have to make code modifications. Now all you have to do is you point the application to the proxy, and the proxy itself will speak to the Redis API or the storage API, or the cache API, that is. Okay? So the way you would do it is instantiate, bring up a Redis, whatever storage API, and get whatever storage you need in terms of size. We'll plug into it, and we'll start writing queries to it. So Redis, for example, it's a key-value pair. The way we would treat it is the key would be the query, and the value would be the SQL results. So we're not writing SQL into the storage. We're treating it as a key-value pair. It doesn't, all it knows is that it's getting a query, getting a key, and then we're getting the value back, and that value is the results. Okay. Did I answer your question, Nicholas?
So Elastic Cache, is that something you could connect to?
Yes. We're tight partners with Redis Labs, with Hazelcast, with AWS. Elasticache is a variant of Redis. It works very well.
How do the agents agree on the quorum when you're handling the failover?
Of here?
Yes.
Okay. We will talk about failover in a second. Yeah. I have that on another slide. Nicholas, another question.
Yeah, so a lot of our queries will look identical, but within 250 milliseconds, the results would be different. Would I define it on a length time interval? What's typical strategies for invalidating data?
Oh, okay, great. I'm surprised. So in computers, this is a little quiz. I'm from the US, so I don't know if this is something in UK that they use as a joke. What are the two most difficult things in computer science?
Naming variables.
Naming variables
Validation.
and cache validations. Pardon me? Yes. So cache and validations is one of the most difficult things to solve in computer science. How do you, if you're going to have a cache, how do you keep it fresh, the data fresh, and not serve out stale data? So that's one of the differentiators about Heimdall is that we can automate not only caching, but we automate invalidation. That's in another slide, and I'll talk about. Let's just talk about the transparent nature of this. So when you install the proxy, notice where it's sitting here, which makes it very unique compared to, let's say, the other proxies. What Heimdall is doing is optimizing SQL from an application perspective. Okay? You drop in the proxy in the application instance. So if you have 3 application instances, you have 3 proxies. So all the data that would have gone to the database is now being served out from the application tier in terms of caching. So the whole point is that you're saving the network latency, which a lot of times developers neglect because they don't have a networking background. But it's that round-trip latency of these duplicate queries that can kill performance. And we solve that by caching at the app tier. Okay? Now, what's really nice about any proxy is that once you put us in, if you're not getting the benefits that you like, you can just take us out in 5 minutes as well. Okay? Because it's just a connection change. These 3 proxies are being managed by a central console for which I will demo. Okay? Another way you can deploy it, that was a distributed mode. You get the best performance by putting it out as close to putting the data as close to the user as possible. Users may want it this way, where you create a separate centralized database proxy tier. You could do it this way too. And this is where all the applications point to a database proxy, and it talks to the database. So you have distributed. Ooh. Distributed mode, and this is centralized mode. Okay? Any questions there on the 2 models? All right. Now we're going to get a few use cases. We'll go a little bit deeper. So this is sort of putting it all together in terms of caching and read-write splitting. The way that the caching works is actually a little bit more intricate and beneficial for you in the sense that in distributed mode, if you have 2 application instances, the proxy will be on each application VM, as I mentioned. What it's going to do is it's going to cache it at 2 levels, a level 1 and a level 2. So all the hot objects will first be stored in the local memory of the instance. And all the remaining cache objects will be stored into the grid cache of your choice. Okay? It could be open source or it could be commercial. Now, if you wanted to, you can just say, well, I don't want to store my hot objects in local cache. I want everything to be in the grid cache. You could do that too. And maybe you don't want to use a grid cache. You want to put everything in local cache. You could do that too. It's completely up to you. So that's why I say that the Heimdall database proxy caches to the cache of your choice or the storage of your choice. It could be in memory or it could be an in-memory data cache. Okay? But this type of level 1 and level 2 caching is very beneficial because if it's being served out, the hot objects from here, the response times are going to be extremely fast. Okay? As opposed to the L2 cache or the database. Okay. So what, any questions there? Yes?
How do you solve the feed your own bytes problem? So typically the feed replica is some kind of asynchronous replication.
Oh, okay. So the heap is configurable, right? Heap size. All memory is configurable. And regarding invalidation, what we do is we leverage the grid cache of your choice, the pub sub interface. And what happens is that whenever there is an update to the database, obviously we see all the SQL, right? Responses, the query and responses. So when any of these proxies receive a write, for example, to the table, it will communicate to the other proxies to invalidate that table.
But is it also going to the master again to feed from in case that the change didn't propagate to your feed replicas?
It will, these proxies communicate with each other via the cache, the grid cache. So in this case, let's say it's Redis. It will use the Redis pub/sub interface to tell all the other proxies to invalidate that table. And as an option, we can also update that cache entry as well. That's how invalidation works. And it's all automated. Now, back to Nicholas's question is, well, how about if there's a lot of writes to that table? Like, where's the balance there? So there's 3 types of modes you can have. You can manually put policies on which queries to cache because you know the application well and its behavior. So you could put that in as a regex rule of what to cache. We also give you recommendations as to what to cache, and I'll show you on our GUI. You can take some of those recommendations, you can take none of the recommendations, or you can take all of the recommendations. And then lastly, what all of our customers do, because it's based on pure math and this type of learning, machine learning, is that you just turn on automation. We'll determine what to cache and what not to cache, and we'll undo the invalidation for you. So you have complete control of what you want to cache or not cache. Okay? Does that answer your question, Nicholas? Yes.
I mean, this is fine as long as it's the same application reading and writing to that one table or how many ever. But if you have other independent applications not going through the Heimdall proxy, you probably have no knowledge about updates made from another source, right?
Okay,
So then you have to follow a timing event, or how do you disable or invalidate your cache?
Okay. So let me repeat that question because that's a really good question. Because in this scenario here, it assumes that we are going through, all queries going to the database is going to be intercepted by the database proxy. So the question one was, which is a good one, is, hey, we have some applications that are going to write to the database that may not go through the proxy. Validation going to happen there. Isn't that going to mess up things? So the first answer is, what you want to do, best practices is you want to create a perimeter such that the proxy will intercept all queries. But if that can't happen, there's a few other options. We have the console, for which you can have a service write to the console whenever there's any type of updates. And then the console will do the invalidation. Another option that what people can do is have a database trigger in the database, such that when there is a write to the table, we will be notified of that write, and we'll do the invalidation. Okay? So there's a few solutions that you can do to get notified if it's not going through a proxy. The other one that people have asked too is, what about stored procedures? So we can cache stored procedures as well. We have a mechanism of understanding the association of tables to a certain level and coming back and doing the invalidation when necessary. Now, we can't do that for dynamic SQL, but there's a certain aspect that we can do it. But good question. I hope I answered it. Any other question? Yes?
Can I ask how flexible is it to tune your caching validation? Because in our world, we have like thousands of servers, and each server has its own local cache. And sometimes one server is on heavy load, and it just bursts load this block, and if it's struggling. So we need to do some fine tuning on that particular node. Is there any flexibility that you can provide in this case? Proxy library generic may not be able to fine tune in these cases.
Okay. So the configuration is based on regex, and because of that, you can it's based on a query level. It's query level caching. So you can fine tune it on a per proxy basis, but within the proxy, it could be based on any field that you want, per user, any ID if you want. So it can be very granular on what you want to cache at a particular proxy level. Okay, so it's quite flexible.
Okay, can you say like tell it just stop sending queries to this node, so like your proxy can have a kind of query list and add this proxy server to it.
Yes.
Just block the queries for the time being, for say 20 minutes or something.
Yes, you can do that. So that would be more like query routing, and we can do that as well. So I didn't put that up there because I don't want to. There's so many features, and I needed to prioritize what are the top ones, but we could do query routing. So for example, for compliance reasons, maybe the queries that are coming in, you need to keep it within a certain region for compliance reasons. So we can route the queries or keep the queries to a particular data center or a particular region. You can filter as well, and you can notify. So there's also a security piece as well. We log everything. We log who did what, when. So this can help in GDPR compliance as well. Okay. Any other questions? All right. So we're going to go back to caching, how it works. It uses real-time analysis. So what we do is we look at the query frequency and variability. So if you get a lot of duplicate queries and it doesn't change much. So you can have a lot of reads, but how about if that table is consistently written to? Then it's not very cacheable. So we won't cache that. But you can override that by putting in, saying, you know, I still want that cached. Okay, you can do that. Not only do we look at the frequency, the query frequency and variability, but we also measure the relative performance of the cache versus the database. So if you're going to Redis to get the cache and it's slower for some reason as opposed to going to the database, then we're not going to cache it. We'll just retrieve it from the database. So our logic goes through a set of rules to ensure that when you're going to go to cache, it's going to provide a performance benefit. That's the whole purpose of this whole exercise here. Again, we can do auto caching or we can provide the recommendations for you, either way. So now I want to talk about the batch processing. I don't know if this is something of interest to you, but I'll go through it and you can ask questions. So the way it works is you have the application who's creating the data. It's going to send a DML request. what the proxy is going to do is it's going to queue it up. And in this situation, it's going to batch a size of 4, but it's configurable. You can batch size of 512 and send that batch size of 4 as a single commit to the application. So where you would have 4 commits, now you have 1 commit overhead. And we found that for singleton DML, this can be very, very beneficial in terms of performance improvement. Okay? Any questions here? Lower CPU overhead due to fewer commits, improves application response times in the sense of it improves DML scale. Yes?
Do the cached stored procedures also generate object IDs? I mean, at the moment, the second commit, if we were doing two separate commits, we take the object ID that's retrieved from the database and put it into the second commit as the parent of the second object.
We should take that offline. I'm not too sure about that. Yeah, don't know about that. But good question. So what happens here is that if any of the, while you're doing the batch, and for some reason there's some type of failover, what we'll do is we will take that transaction out, we'll do a retry, and we'll log it. Okay? But this is optimizing writes. We talked about HTAP, hybrid transactional analytical processing. I'll just touch on this real quick. If you put the Heimdall proxy in the middle, it can route the analytics traffic, the OLAP traffic, to your data warehouse, whether it be Redshift, Greenplum, or Citus Data, which is Microsoft. And then it will route the transactional traffic to, let's say, a generic transactional database. This can greatly speed up your application by breaking it out. Okay? And let's hit the demo. You ready for the demo? All right. What I have here is the GUI, the central console that controls all the proxies. If you remember on the diagram, there's just really 2 components of the database proxy. There's a proxy, which is the data plane that you would put on every application instance. And then you would have a control plane, which manages all those proxies. They're completely separate. So if the control plane died, the proxies would still be running. Okay? They're completely separate. So from an operational standpoint, it's really good. Now, in this, I think it may have died on me here. So right now, there's no caching at all, as you saw on the dashboard here. It's 0. Cache hit rate is 0. Nothing's going on. And all it takes for caching, literally, is we have logging enabled, but it's really a click of this button right here. It enables cache. There's a default TTL, an expiry. You can put whatever you like. But I just want to just show you how simple it is. I click this button here. I put commit. And let's go to the dashboard. Oh, it is not running. Excuse me, analytics. I was having some wireless issues here. And it is not running. I am sorry. I'm having some technical wireless issues. I apologize. But let's just go through, I'll go through the analytics really quickly. It's not running. Let's see if it'll come back. We'll see if it comes back. I apologize. While it's analyzing, is there any questions about proxies in general, database proxies, that I can help answer?
How do you handle the automatic failover?
Automatic failover. Okay, so automatic failover is another feature that we have. And what it does is it senses the health of the database instance. And if one is bad, as I mentioned, it will hold the front-end connection, the application connection. It will queue up the connection and then create another connection to the standby database and gracefully fail over.
Is that, I mean, I'm more interested in how does it decide which instance to fail over to?
You would, how does it know which instance it should fail over to? It is based on your configuration.
Okay.
So you configure the rule as to where are the instances, which ones are the reads, which ones are the writes, and which one's the standby. And it can be sophisticated. You can also weight them as well. How much traffic should go to this one versus the other one, okay?
So in the instance where you have one write and say two reads, it's not going to determine automatically which one of the reads to use. It's a configuration one. You have to specify, excuse me, which one it has to promote as the.
Yeah, you need to specify that.
Okay.
And then you can weight it also. It doesn't, the load distribution can be uneven as well. I got 1 minute left, and I'll just show you the analytics here, because I think that's worth the price of admission, even beyond what it could do in terms of execution. On our analytics tab, we give you very good information of performance analytics. Cache hit rate, it says cache time, which is cache response time, the DB response time, the overall response time. So if you have the overall response time, we can also give you, so we give you the client-side and server-side analytics. So if you have the database, the overall response time, and you have the DB response time, what can that give you? Little quiz question here. Correct. So this is a very good tool to figure out where your SQL bottleneck is. Is it on the application side? Is it on the database processing side? Or is it a network latency? Okay? This can really help in the sense that we're grabbing information also from your database as well. Let's say from Postgres. And such that it's on a single pane glass in terms of visibility. Lastly, the other part that I can mention to you is that we, as developers, do you guys find the query extraction plan useful? Does anyone use that? Can I have a show of hands who uses the query extraction plan? Okay, some of you. You can, if you click on the query there, on the right side, will expose the query extraction plan. Now, some people may say, well, you know, we can get that from other tools. That's true. I mean, that's not a big deal. But to have all of that at the user's touch altogether of server-side, client-side, and the query extraction plan of now how your query is in your code is behaving is very, very beneficial. So this one screenshot here gives you a really good idea of how your application to database is performing. Okay? And this is just part of the tool. Okay? And with that, I'm going to have to end. And if you have any other questions, we do have a booth there, and I could talk to you afterwards. Thank you.